Hey everyone! Today we are going to be tackling about rational equations and how to solve them. But before anything else, what is a rational equation? A rational equation is an equation involving rational expressions. It contains at least one fraction whose numerator and denominator are both polynomials. Here we have some examples to be able to further understand what rational equations are. Next up, we are going to be learning the method and how to solve rational equations. In order to solve them, we must first and foremost know the following four basic steps. First, we must find the least common denominator. Second, we have to multiply both sides by the LCD. Third is simplifying the equation. And last but not the least, we must review our answer. Now, let us jump into the examples that we have prepared and work on them together. For the first example, here we have our given 2x plus 2 over 4 is equals to x over 3. First, like we have said before, we must first find the least common denominator of the equation, and the least common denominator of 4 and 3 is 12. So next, we shall multiply both sides by the LCD so that the equation will now look like this. For 2x plus 2 over 4, we will be able to distribute 12 with the numerator and divide it by 4 so that it will now become 6x plus 6. Next, let us now transfer over to the other side. If we multiply 12 with x and divide it with 3, then the answer will be 4x. And now, there we have successfully multiplied the LCD to both sides. Next, we should simplify them by first combining like terms, which is 6x and 4x. Since we will be transposing 6x over to the other side, don't forget to change its sign so that it will now become negative 6x. Negative 6x minus 4x is equals to negative 2x. So now we have our equation that will be 6 is equals to negative 2x. We must make sure that only x will remain on the other side. So we shall divide both sides with a negative 2. And now we have our x, which is negative 3. To check if the answer that we got right was correct, then we shall substitute our x to the equation. And if both sides have the same answer, then that means that we did everything right. If they don't, however, then we should review and go back over the equation to check on what went wrong. Let us now move forward to the second example, which is x minus 4 over 4 plus x over 3 is equals to 6. Take a moment to pause the video and apply the steps that were shown on the first example. For example number 2, our x is equals to 12. Did you get the right answer? No? Well then, here's how. The LCD of 4 and 3 is 12. Since 6 is a whole number and whole numbers all have a denominator of 1, in this case, it is alright to disregard the 1 since it doesn't affect our answer anyway. Next, multiplying the LCD on both sides so our equation should now look like this. Multiply 12 to both sides. Let us first combine the consonants 12 and 6, which will give us the answer of 72. Moving on to the other side, we shall divide 12 by 4 and 3 in order to eliminate the fractions. 12 divided by 4 is equals to 3, which will give us 3x minus 4. Next, 12 divided by 3 is equals to 4, which will give us 4x. Our equation will now look like this. 3x minus 4 plus 4x is equals to 72. After that, we move on to the next step, which is to simplify 3x minus 12 plus 4x is equals to 72. In order to do that again, we should combine the like terms, which we can do so by transferring negative 12 over to the other side, not forgetting to change its sign. So now we have 7x is equals to 72. Next, in order for only x to remain, we must divide both sides by 7, and now we have our answer, which is 12. Take it easy and take a deep breath. We still have 3 more examples to go. Let's move forward to the third example, which is k plus 1 over 3 minus k over 5 is equals to 3. Once again, feel free to pause the video and solve it for yourself. But if you aren't feeling confident enough yet, then you are totally free to solve it with us as well. Again, first we must find the LCD. The LCD of 3 and 5 is 15. So like earlier, since 3 is a whole number whose denominator is 1, it is alright to disregard the 1. Following the next step, we multiply both sides by 15 with our equation now turning out like this. Next, we follow the next step again, which is to simplify. First, we solve the constants and eliminate the fractions. We multiply 15 and 3, that will give us the answer of 45. Now, let us transfer to the other side. 15 divided by 3 is equals to 5. That will give us the result of 5k plus 1. And 15 divided by 5 is equals to 3. That will give us the result of 3k. Now, our equation will look like this. If we simplify it further, it shall become 5k plus 5 minus 3k is equals to 45. Next again, we combine like terms by transposing 5 over to the other side, not forgetting to change its sign, making it 2k is equals to 40. Divide both sides by 2 to retain k, and 40 divided by 2 is equals to 20. Therefore, k is equals to 20. Are you now starting to get that feeling that it's easy peasy? Well, here's the next example. Mahirap mag-move on, but in math, we have no choice but to do so. So next, the fourth example will be 5 over y minus 1 plus 3 over y minus 3 is equals to 8 over y minus 2. Yes, you may pause the video to cry. Just kidding. Feel free to pause the video and solve it for yourself. Take your time, no pressure. For example number 4, it is quite a long process due to its LCD being of greater value, but we have to find it. So first, let us find the LCD since the denominators all differ from each other. We will take it all of them as our LCD. Hence, our LCD will be y minus 1, y minus 3, and y minus 2. So that our equation will now look like this. And next, we will multiply and eliminate the fractions. For 5 over y minus 1, we'd only be able to cancel y minus 1. So we'd have the result of y minus 2, y minus 3. For 3 over y minus 3, we'd only be able to cancel y minus 3. So we'd have the result of 5 y minus 1, y minus 2. Onto the next side, 8 over y minus 2, we'd only be able to cancel y minus 2. So we'd have the result 8y minus 1, y minus 3. Our equation will now look like this. What do you notice? Do you see binomials? Yes? If that's the case, then what we should do is use the FOIL method, which will give us the result of. Now, let us distribute the constants. Distribute 5 to y squared, negative 5y, and 6. Then distribute 3 to y squared, negative 3y, and 2. Then finally, 8 to y squared, negative 4 and 3, which will give us the result of 5y to the power of 2 minus 25y plus 30 plus 3y to the power of 2 minus 9y plus 6 is equals to 8y to the power of 2 minus 32y plus 24. Then combine like terms. Phew, this is a quite long equation. Are you getting tired? Let us first focus on combining like terms in the first half. The terms that we can combine here are 5y squared and 3y squared, turning into 8y squared. Next, we have negative 25y and negative 9y for a total of negative 34y. And lastly, 30 and 6, which is 36. So now we have 8y squared minus 34y plus 36 is equals to 8y squared minus 32y plus 24. We can't stop there yet. We have to look for y. In order to do that, let us transpose like terms. And to do that, we must first transfer the 8y squared from the second equation, not forgetting to change its sign into negative. So now we can subtract that with the positive 8y squared in the first equation. Next, we transpose negative 34y over to the other equation and positive 24 to the other side, not forgetting to change both of their signs. So now we have 6 minus 24 is equals to negative 32y plus 34y. If we simplify that, we now have 12 is equals to negative 2y. Since we have to make sure that only our variable will be left on one side, we have to get rid of the negative 2 beside y by dividing both sides with negative 2. Simplify, and finally, we get y is equals to negative 6. I hope we haven't lost you along the way. Still haven't felt challenged? Here's one last example. Let us now solve for our given, which is 5 over 2x minus 1 minus 7 over 3x plus 2 is equals to 9 over 6x squared plus x minus 2. What did you notice with the denominator of the third? It can be factored, right? So before we find our LCD, let us factor it first, which will now give us 2x minus 1 and 3x plus 2. After we factor, now what do you see? The binomial is exactly similar to the first two fractions. In this, we can say that our LCD is 2x minus 1 and 3x plus 2. Next, we multiply the LCD to both sides and eliminate the fractions so that our equation will now be 3x plus 2, 5 minus 7, 2x minus 1 is equals to 9. To simplify, we distribute the constants to make it into 15x plus 10 minus 14x plus 7 is equals to 9. Next, we combine like terms and now we have x plus 17 is equals to 9. In order for only x to remain on one side, we transpose our 17 over to beside 9. Simplify, and now we have our answer, which is x is equals to negative 8. And that's it for our examples. Again, to review what we have learned today, rational equations are equations that involve rational functions. They must contain at least one fraction, and the numerator and denominator of those fractions must be both polynomials. The method to solve them would be: first, find the LCD. Second, multiply the LCD to both sides. Third, simplify. And to make sure that you've got the right answer, the fourth is check. That's all, and thank you so much for clicking this video, and we sincerely hope that you had understood the examples and solutions given. Don't forget to like and subscribe to our channel. Have a wonderful study time. Till next time, adios amigos.